Okay, grade 10. In this video, you will find a solution of the exercises from the book, page 184. They were given as homework for yesterday. So, now, number 1. What is the effect of the application of a force on a body? As you all know, whenever I have a force applied on a body, many things might happen. The first thing, a force can set an object to motion. The second thing, it can stop its motion. So the object is moving and the force stops it. It can speed it up. It can slow it down. So it's just changing the velocity of this object, and it can change its direction or change its shape. So all these might happen whenever you are applying a force on an object. 2. What is meant by the word interaction? Give examples of interactions at a distance and of contact. So, whenever I say interaction, it's the existence of two forces at the same time. None of them would exist if the other one didn't exist. So, interaction at a distance. Example, I have two balls that are charged with alike charges, and they repel. If you remember from the chapter concerning electrostatics, if I have two balls and they're not touching each other, there's a distance between them, and they have alike charges, they will repel. This is an example of interaction at a distance. Now, interaction of contact, there are plenty of examples. You can say a racket and a tennis ball. So whenever you are hitting the ball with a racket, these two objects are touching each other, so this is an interaction of contact. 3. How do you represent a force? And the answer is, a force is represented by a vector. 4. A body falls under the action of the Earth's attraction. Represent the interaction between the Earth and the body. So, this is the Earth. I have a body, which is in this case the green ball. So the black arrow means the attraction of the Earth on this ball, and I have the purple vector, which is exactly opposite to the black vector. So these two are the action and the reaction, which means they are the interaction between the Earth and the body. 5. How can you determine the resultant of two forces, which are collinear or concurrent? So, in the first case, I have two options. If they have the same direction, like in this picture, F1 and F2, so you add them. So the net force of these two forces is F1 plus F2. Now, if they don't have the same direction, you have to subtract them. Like in this figure, it's F2 and F1, so the net force would be F2 minus F1 to get the positive answer. And finally, if they have a point in common, we complete the parallelogram. Example. This is the black arrow is representing a force, and the yellow arrow is representing another force. As you can see, they are intersecting. So how am I going to find the resultant force or the net force of both of them? The first thing you have to do, you draw the first force again, and the second force starting with the same point that the first one started. So now you have two sides of the parallelogram. You complete the parallelogram and you draw the diagonal. So the red vector is the resultant force of the two vectors, or the two forces, the black one and the yellow one. True or false, correct the wrong statements. A. When two bodies interact, they may or may not be in contact with each other. This is true. We just saw an example about non-contact force that have interaction, so they don't have to be in contact. They can be in contact and they can be at a distance from each other. B. When a body and the Earth interact, they are necessarily in contact with each other. This is false. They can be in contact or no, because Earth's gravity is a non-contact force. And C, if object A exerts a force F on object B, then after a certain time, object B exerts a force F prime on object A. This is false, because it's not after a certain time, it's at the same time. And it's also wrong because it's not F prime, it's exactly F. In the opposite direction, it has to be minus F. Because when we talk about vectors, the minus means the opposite direction. So it has to be at the same time, it has to have the same magnitude, but it has to be opposite in direction. Thank you, grade 10.